Assalamualaikum guys, and welcome back to my YouTube channel Learn Something. In the previous video we have discussed two measures of central tendencies, one of which was arithmetic mean and the second one was geometric mean. And now today we are going to discuss the third measure of central tendency, which is harmonic mean. So let's start from its definition. First of all, we will define harmonic mean, and then we will take a simple example so we can easily know that what is harmonic mean. So let's start from the definition of harmonic mean. So the definition of harmonic mean is defined as the reciprocal of the arithmetic mean, the reciprocal of the arithmetic mean of the reciprocal of the values is called harmonic mean. The definition of harmonic mean is the reciprocal of the arithmetic mean of the reciprocal of the values is called harmonic mean. First of all, we will discuss the word reciprocal, that what is a reciprocal. So we will take 1 to 2 minutes to know that what is reciprocal. So a reciprocal is something like if we have a number in p by q form, then so I can write, so you can easily know that what I am talking about the reciprocal. So let's suppose we are writing on the next page. Let's suppose we have a p by q form. P by q form, we have a number in p by q form. Let's say we have a number say 3 by 5. So the 3 is numerator and the 5 is denominator. What we are talking to discuss, we are discussing reciprocal. We are getting to know that what is reciprocal, what is meant by reciprocal, and after that we will discuss the whole definition of harmonic mean. Simply, first of all, we will discuss that what is reciprocal. So I am telling you that whenever we have a number or we have a given equations or we have observations or something, we have data in p by q form. P by q form means in which the upper one we called numerator and the lower one we called denominator, and the reciprocal means that when we change the positions of numerator and denominator, then we called this as reciprocal. Simply, if we change the value of 3 and 5, means what is 3? 3 is numerator, and the 5, what is 5? 5 is denominator. If we change the values of each other, means the numerator, we are getting numerator to the denominator and denominator to the numerator place. Mean we write 5 by 3. 5 is what thing? 5 is denominator and 3 is numerator. What we do, we just simply do it that we can change the places of denominator and numerator. So that's we called this method as the reciprocal. We call this action as reciprocal. We do a reciprocal. So that's the reciprocal. Reciprocal means when we change the place of numerator and denominator. So we call this as a reciprocal. So let's move to the original definition of harmonic mean. The reciprocal of the arithmetic mean of the reciprocal of the values is called harmonic mean. In this definition, we are getting to know the harmonic mean, the reciprocal of arithmetic mean. First of all, we are given that the reciprocal of arithmetic mean. We have discussed in previous videos that what's arithmetic mean. Arithmetic mean is number of observations. Arithmetic mean is what thing? Observations divided by the number of observations. So the arithmetic mean is, we have discussed in previous videos, x1 plus x2 plus x3 plus up to xn divided by what thing? N. N is what thing? N is number of observations, and the upper x1 x2 x3 up to xn, that is what thing? These are the observations. We simply add them. So arithmetic mean, we have discussed in previous videos about arithmetic mean. You can easily see my videos, watch my videos of arithmetic mean, so you can easily get to know that what's arithmetic mean. So today we are discussing harmonic mean. So let's come towards our main topic, the reciprocal of arithmetic mean. First of all, we can do the reciprocal of arithmetic mean, and the next one is the reciprocal of the arithmetic mean of the reciprocal of the values. First we should take the reciprocal of the values of arithmetic mean. These are the values, observations. We call these values as observations are values. We would take the reciprocal of these values, and then we would take the whole reciprocal of arithmetic mean. Okay, you understand? You all understand? And the next thing is the notation of arithmetic mean. We denote harmonic mean. We denote the harmonic mean by capital H, and we are going to write the formula of harmonic mean from the definition of harmonic mean. The reciprocal of arithmetic mean of the reciprocal of values. We would take the reciprocal of these values. x1 plus x2, we would take the reciprocal of these values. So reciprocal of these values comes out 1 by x1 plus 1 by x2 plus 1 by x3 up to 1 by xn divided by n. But in the next step, we can simply get the reciprocal of the values of arithmetic mean. But we would take the reciprocal of arithmetic mean. We would take as a whole the mean of arithmetic. We would whole take the reciprocal of arithmetic mean. So we are taking the reciprocal of the whole this thing, which is turned out to be, this n will go to the numerator side, and the numerator observations what comes to the denominator side. So this is n divided by 1 by x1 plus 1 by x2 plus dot 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 up to 1 by xn. So this is the formula of harmonic mean, and that formula comes out from the definition of harmonic mean, and that is the mathematical formula of harmonic mean. And the definition of harmonic mean is the reciprocal of the arithmetic mean of the reciprocal of the values is called harmonic mean. So you can easily see, watch, and you can easily see in the formula of harmonic mean that the formula of harmonic mean is simply the reciprocal of arithmetic mean and the values and the reciprocal of the values of arithmetic mean. Got it? So we would move to the example of harmonic mean. The example of harmonic mean is, we would take just a simple example to understand the harmonic mean. We would apply the formula of harmonic mean so we can find the harmonic mean. The example, we are taking a simple example. Suppose we have given an example. Suppose we have a car. Suppose we have a car moving. We have a car moving at the rate of. We have a car moving at the rate of 15 km per hour during first 30 kilometer and moving 20 kilometer per hour during the next 30 kilometer and again moving at the rate of 15 kilometer per hour during the next 30 kilometer, and we have to find the harmonic mean. We have to find the harmonic mean of car. So starting from the solution, what we have given an example that suppose we have a car moving at the rate of 15 km per hour during the first 30 km. In this example, they are saying that suppose they have a car moving at the rate of 15 km per hour during the first 30 km. In the first 30 km, the car is moving at the rate of 15 km per hour, and in the next 30 km, the car is moving 20 km per hour, and after that, in the next 30 km, the car is moving 15 km per hour, and what we have to find? We have to find the harmonic mean of that car. So first of all, you have to see that starting from the solution, that you see clearly that the distance we are given is a constant. You clearly see that we have given the distance which is constant. You clearly see that in the first 30 km the car is moving 15 km per hour, and in the next 30 km the car is moving 15 km, and the next 30 km the car is moving 20 km, and in the last 30 km the car is moving 15 km per hour. You see that the distance is constant. Here is 30 km and the next 30 km and the next 30 km. You clearly see that the distance is constant, and what thing is changes? You clearly see that the time is changing. At the first 30 km the time was 50 km per hour, and in the next 30 km the time changes to 20 km per hour. It would increase 5 km per hour, and in the next 30 km the car is moving 15 km per hour. So the time is changing, the distance is constant, but the time is changing, or we say that time is a variable. Variable means it got some changes after some kilometer the car is moving. So we have to find the harmonic mean. So you clearly see that the distance is constant, so we can't take this value because distance is almost constant, almost not, but I think perfectly it's constant, because in the first you see that the 30 km at the first, and the second, next again 30 km, and in the last again 30 km. So distance is constant. What thing is changes? Changes occurs in the time. Changes occurs in the time. In the first 30 km 15 km per hour the car is moving, and in the next 30 km car is moving 20 km per hour, and in the next 30 km the car is moving 15 km per hour. You see that the time is changes after the car moving. So we have to got the changes. This one 15 km, 20 km, and the next 15 km is the observation we have. So the formula of harmonic mean is that we have to take the reciprocal of the values of that. 15, so we have to write 1 over 15 plus 1 divided by 20 reciprocal, taking reciprocal, and again 15, 1 by 15 whole divided by number of observations. And we have what number of observations? Count 1, 2 and 3, so we would write 3. But the formula of harmonic mean is what? We have to again take the reciprocal of this whole formula, and this comes out that you would write 3 in the numerator and 1 over 15 plus 1 over 20 plus 1 over 15 in the denominator. And you can easily solve this to get the harmonic mean. So I am solving, taking the LCM of these. It would I think it would be something like 60, I think maybe 60. You can solve easily. This is some mathematical values. You can easily solve this. I can solve it, but it would take some times, and we are getting very difficulties when uploading the videos. So you can at home you can easily calculate these values taking the LCM of these denominators, and after that you can better know rather than me that what you can do about the calculations. Just simply take the LCM. I think it would be 60 and something like these values, and you can divide these with this, and after that you got some p by q form of that, and after that it will be something like in that place values it would be in the upward something like 3 multiplied by something we have got. We have to just suppose that we have got in the place of 60 we have got 9 divided by, and in that value we have got I think just we are supposing 15, so it would be 9 3 is 27 divided by 15. Now if these values are cancelling, so cancel each out from the table at the table of 9. Sorry, 3 5 is 15, 3 9 is so 9 by 5 is our answer. 9 by 5 is the harmonic mean of that question or that example we have taken. So in the next videos we will discuss the fourth measure of central tendency, which is median. So in the next video inshallah we will discuss the fourth measure of central tendency. So thank you very much.